Hi, hello everyone. My name is Vivek. I am a software developer and I make videos about containers, Kubernetes, Go as a programming language, distributed systems, and sometimes about software engineering in general. So if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should maybe follow me on Twitter as well. In the last video, we started writing a Kubernetes custom API server or aggregated API that is going to serve the resources of type cluster. So this is the project that I had already created in one of my YouTube playlists. So this particular project introduces a resource called cluster using custom resource definitions. So I wanted to do the exact same thing, but the new resource that we have highlighted here is not going to be served by main API server. It's not going to be handled using CRDs. Uh, the new project that I have started, that is going to obviously introduce a new resource called cluster with the same schema, but it's going to be served by, or it's going to be handled by, aggregated API server. And the first part of the video was uploaded some weeks back, and this is the GitHub repo for that project. And before actually moving forward, let's go ahead and quickly try to summarize what exactly are we building. So like I said, this is something that I have already built. It's done using CRDs. When you create a cluster resource, an actual DigitalOcean cluster is created on DigitalOcean. And we would like to do or achieve the exact same thing, but not using CRDs, instead using aggregated API servers. So I have already talked about CRDs and aggregated API servers in one of the previous videos. And that is the reason I did not talk about the differences between these two things in my last video. And I'm not going to talk about that even in this video. If you want to kind of familiarize yourself with the differences, please, I would recommend watching that video. Before actually going ahead, in this video, I would like to very briefly kind of relate whatever I talked with these two diagrams. So whenever we try to interact with Kubernetes, the request goes to main API server. So this is the, if you see here, this is the main API server. This is where the request goes to. And if the resource that the request came for is either standard Kubernetes resource, for example, let's say pod services, ingresses, etc., that resource goes through the handler chain and then obviously goes to this entire, I would say, workflow. But if if the resource that the request came for is either standard resource or if it's for, let's say, custom resource definition, even in that case the request goes to this particular way, I would say. And if the resource that request came for is being served by aggregated API server, in that case cube aggregated figures that out automatically, not really automatically, but by looking at API service resources. So by looking at those resources, cube aggregator figures out that this resource is not served by main API server. This resource that the request came for is served by aggregated API server, and that's when the cube aggregator proxies that request to the custom kind of API server that we have here. Now, one thing that I would like to highlight is when we create a custom API server, we let main API server know about this custom API server using a resource called API service. So we create a resource called API service, and by looking at that resource, main API server, or let's say cube aggregator, can figure out which particular custom API server serves which particular resource from which group and version, let's say, right? And that is how, let's say, main API server and custom API server are related. I just wanted to kind of clarify this thing here. And in this particular playlist that we are building, we are writing this particular custom API server. So we have already started writing this. This is let's say very well written REST API server. And once we have written this properly, this is going to be kind of installed in Kubernetes using API service resource that we just talked about, and we are going to look into that in future videos. So this is the resource. This is the server, not resource, that is going to serve cluster resources that we talked about. And yeah, let's just go ahead and start working on whatever we left in the last video. So in the last video, we were able to run our API server successfully, and when we ran this /APIs resource, this is the error that we got, and we need to kind of make this endpoint work, because this is the endpoint that tells us what are the resources that are available in the API server. So, and this is the resource that gets called when we run this particular command. I showed this particular thing in the last video as well. So if you see, to figure out what are all the API resources that are available, /APIs is called, and that's what we are trying to call. That's the resource path that I'm trying to call in the new API server that we have written. I would like to highlight that when we ran this command, we are not interacting with our custom API server. Our custom API server right now is running locally on my machine, just using go run command. And that's the reason when we tried to interact with that, we just used localhost 9443. And yeah, so let's just go ahead and try to look into that problem. But before actually solving that problem, there were some of the issues that I noticed that I would like to fix quickly. So if you remember, we talked about internal and external version in the last video of the resource of the API. Internal version is just used by the API server to do the logic validation and things like that, and external version is the resource version using which users interact with the API. And if I look into register, for this is register.go for internal version, and I have specified when I copied the files, I just used the version v1 alpha 1, but we cannot use v1 alpha 1 here because it's internal version. And to specify the internal version, what we have to do is we have to use runtime.api version internal, and it just kind of implies that now the version is this particular thing. And so it basically makes sure that this particular version has v1 and this version has internal. That's the kind of significance of this. The other thing that I would like to highlight is we don't really need these JSON tags here, and we don't need these JSON tags because, like I said, internal versions are used by the main just the API server. They are not basically converted into other formats, or they are not marshaled, unmarshaled, to get transferred to some other place. And that is the reason, if we don't need to transfer the type, we don't really have to add the JSON tags. And the other thing is, some of the kind of code generators use this JSON tag to figure out if the type.go is for the internal type or external type. They look into this JSON tag to figure out if the types.go is for internal type or external type. And that is the reason, if it's for internal type, it's better basically to just kind of remove these tags. And that's what I'm going to very quickly do. I'm pretty sure there might be a better way of doing this, but yeah, this works. Okay, all right. So now that we have fixed that, let's just go ahead. I just noticed we have a typo here. Instead of cluster status, we have something else. We will fix this later. So, and now we are going to go ahead and fix this problem. The problem is kind of, yeah, it might be obvious for some of us. It says that this particular type v1.status is not really kind of registered in the scheme. So let's just go ahead and try to register that type. So open scheme.go, and we have a scheme here, and let's create a function in it. It would be executed whenever this package gets loaded. And in this init function, uh, I'm going to register the types that we have, the internal type as well as the external type. And let's go ahead and open the book that we were referring to quickly refer how exactly we can do that. I want to refer this to make sure that if you go through the book, you can relate to how things are happening here. So I should have already opened that, but it's okay. Hold on. Yeah, it's okay. I think if you're not able to find that, let's just go ahead and add our types to this scheme that we have created. So we are going to use this syntax and cluster. It's something like this: cluster dot add to scheme, and then we are going to pass the scheme here. What it does is it basically registers this internal type. So runtime.api-version internal, it registers the internal type to the scheme that we have passed here, and we have initialized the scheme. And the other thing that we would like to do is we would also like to register the external type v1 alpha 1. So v1 alpha 1 dot add to scheme, and we would like to add that to scheme again. So we have what it does is, now at least the if anybody, let's say, queries or looks into the scheme, they would be able to see two types registered into the scheme, and those two types are cluster v1 alpha 1 and clusters internal type. If I did not talk about scheme already, scheme is, let's say, in a very naive words, it's just a map between the Go type and its group version kind, and then obviously a lot of, not a lot of, but other things as well. For examples, the conversions, the defaulting functions, and things like that. You can actually look into that by going at this type. So if you see, scheme is just mapping between, let's say, group version kind to type, and then type to GVK, and then things like that, defaulter functions. Yeah, so I think that's what the scheme is. Now that we have done this, let's just go ahead and try to run the server again, and then we are going to query the same endpoint called API. So if you see the problem here, it says double registration of different types for internal. So it looks like for internal version, we are registering it twice. And to fix that, we are going to remove this line from here so that we are only registering this particular type once. And let's just go ahead and try to run it again. And then we are going to query the API's endpoint again. And if you see, it clearly says that the user using which we are trying to access the custom API server. So if we go ahead and look into this diagram once again, right now the requests that we are making, these requests are directly going to basically this custom API server. They are, because these are curl requests, so they are obviously not going via the main API server. But for authentication and authorization, our custom API server is still delegating that request to main API server, and main API server says that this particular user, system colon anonymous, is not basically authorized to query that path. And to fix that, what I'm going to do is I am going to create a cluster role binding. This is a standard kind of Kubernetes thing. So this cluster role binding just enables the user system anonymous to be cluster admin, so that it can do anything. It's not really a good practice on a production scenario, but we are just trying to see things here. So now if we run the curl again, we would be able to get at least the success response. And it says that there are no resources registered, not registered, but there are no resources available in this custom API server that we have written. But you might think that we just registered these two types into the scheme. So the thing is, let me quickly go ahead and create a readme, and roughly I'm just gonna mention, so basically making an API available in custom API server involves two main things. One is registering that API / type in scheme, and the other is installing that API using installing that API using, yeah, I mean, there is a utility, I would say, installing that API using mux, so that it's actually available or registered as an endpoint in the on the server. So these are the two things that are actually required to make your resource available as an endpoint. So we have just done the first thing here, and we are going to do second later, I would say, very soon. So now that we have the APIs, what it means is, if we go ahead and look into this diagram once again, so we don't have, we have scheme, but we just have two types, but we don't actually have any resource available, and most of the things are I would say empty here. We don't have admission, we don't have REST logic, we just have, let's say, a kind of skeleton black box custom API server that is able to respond that it doesn't have any resources available. So that's what we were able to do till now. So now that we know we have a skeleton server with recommended options and config that is just serving some standard requests, I would also like to show you some other requests that are being served already. So health is working, and if you mistype there, you would be able to see all the kind of requests that are available in the custom API server, even though we have not actually written anything. So now what we are going to do is, before actually moving forward, I would like to very briefly talk about the conversion of the APIs again. So if you remember, in the last video, we talked about using custom API server, we can serve many versions of the same resource. So let's say we have cluster resource, we can serve v1 alpha 1, v1 beta 1, and maybe v1 beta 2. So the API server, the custom API server, should seamlessly be able to convert these resources between each other. So for example, if I am trying to create the v1 alpha 1 resource, but my storage version is v1 beta 1, in that case, API server should easily be able to convert from v1 alpha 1 to v1 beta 2. And this happens using this thing called hub and spoke architecture. So in case of hub and spoke, the spokes are going to be these versions, and the hub is going to be the internal version. So to convert from v1 alpha 1 to v1 beta 2, the conversion is going to happen from v1 alpha 1 to internal version first, and then from internal the conversion is going to happen to v1 beta 1 or v1 beta 2, whatever is required. And if we look into this conversion, this is already generated, and one thing that I would like to highlight here is the same scheme that we looked into when we registered the resources. That scheme needs to know about the conversion functions. So we have this conversion function here, and when we ran the code generator for our types, these conversion functions were generated, and they are registered to our scheme builder, local scheme builder, using register function. Now what we can do here is, let's say we are not really satisfied with one of these conversion functions. What we can do is we can go ahead and we can write our own conversion function, in the same directory in a file called conversion.go. So let's say if I go ahead and create a file called conversion.go in the same directory where the generated conversion.go is, and I create a function that converts from one type to another type. So let's say convert type 1 to type 2. This is not the exact syntax. Exact syntax of the function name can obviously be figured out by looking at this function name here. So convert, then obviously package and type. So for example, v1 alpha 1 cluster list to cluster list. Does that make sense? I can try to explain it very quickly. So what it says is convert package and then type from that package to package again, and then type from that package. So cluster list, this particular function is going to convert cluster list from v1 alpha 1 to cluster list from cluster package, and this cluster package, if you remember, is the internal type. I hope that makes sense. So what I was trying to say is, if you want to write your own manual conversion functions, you can go ahead and create them in the conversion.go in the same directory where generated conversion.go is, and you can name the function properly. If the function is named properly and you run the code generator, your functions that are written, they would take precedence from the generated ones. What that means is, if you have this particular function written in your manually written conversion.go, that function is not going to get generated in the generated conversion.go file. I hope that makes sense. So now that we are going to, I think, talk about this in a much more detail when we actually implement conversion, let's say a custom conversion in future. But for now, just kind of keep in mind that if we are writing our own conversion functions in conversion.go, those are prioritized from the generated ones, because code generator wouldn't even generate the functions that are already written. The other thing that I would like to highlight is, if you remember, in types.go, at least the external ones, we should have we don't have defaulters here, but let's say if we want to generate, we have defaulter here. So what it does is, let's say if you talk about pods, right? When you create a pod resource, even if you do not specify the service account for that pod, a default service account is already kind of used for every pod, or a default service account is added in the pod resource automatically. And that is the kind of concept of defaulting, I would say. So for example, if I want to create a cluster resource and I want to configure some values by default, if they are not specified by users, all of those things can be handled using this mechanism of defaulting, and we can actually go ahead and we don't see default generated here. And the reason is, even though we have, like conversion, we don't have defaulting logic generated. And the reason is, if we go to generate code.sh, we are generating everything, but we are not generating defaulters, let's say. So if we want to do that, all we have to do is we have to, like we are running, let's say, client gen, listers and all of these generators, we just have to add the defaulters in. And as soon as we add the defaulters in and we run the code generator again, we would be able to see the code generator. So let's go ahead and try to add the defaulter. So I'm just going to copy and paste the code here. And now I think we can just go ahead and run the generate code.sh. So okay, and hack generate code.sh. So it's going to generate obviously the client sets and every other thing that we already have. And okay, so it is generating the defaults and everything is generated. We also have the defaults here. I'm going to talk about this very soon. So let's fix this very quickly, because our scheme builder is called scheme builder. And if you see here, register defaults is actually generated, but it doesn't really have anything. And the reason is, we don't have any defaulting logic right now. So like conversion.go, if you remember, we talked about conversion.go. If we go ahead and create a file called defaults.go, and in that I think it's called default.go, and I was just checking my notes. And in default.go, if I try to write a function called, let's just set defaults and underscore type, and then if I try to generate the code again, that particular function would be used in the register defaults. I hope that that makes sense. And then, like we register the conversion functions, we can also register the defaults functions. Again, we are going to implement this in future, so we are going to talk about that in much more detail. But for now, just keep in mind that if we have some defaults generated and we run the defaulted code, that code generator is going to generate register default function, and all the functions from defaults.go, if they are named properly, are going to be called from here or are going to be used here. I hope that makes sense. So now that we have the kind of, let's say, skeleton ready, we understand what conversion is, what defaulting is, what exactly hubs and spokes are, internal and external versions. What we would like to do is, we would actually like to implement the REST endpoints for these resources that we just looked into, especially that cluster resource. So when we say we want to implement the REST endpoints, we would like to implement the REST verbs for that resource. So for example, for cluster resource, we would be able to get that resource. We should be able to put or patch or create that resource and things like that. And in case of Kubernetes, or in case of, let's say, custom API server, that is done using registry, I would say. So let's say registry is, let's say, a default implementation of those verbs that we just talked about. So let's say we have I'm not going to push this readme.md in this state, but just for kind of rough sketch, let's say we have cluster, and for this cluster we would like to implement some REST endpoints, create, get, let's say delete, and things like that. And these things are implemented by something called generic registry. So we don't have to write implementation of these functions manually. We can just use, let's say, generic registry that already has the implementation of these verbs, HTTP verbs. And most of the standard Kubernetes resources just use the same generic registry. So for example, if you look into pods implementation, you would see that when the resource is created, the generic registry is used to actually create that resource, and we are going to use the same thing. The in case of main API server, there are some resources that behave differently. For example, let's say even subject access review, that resource is not stored in etcd, and because of that its handling would be different. Its create would be entirely different from pod's create method. And that is the reason for some resources, subject access review is one example, generic registry is not used. So again, if I try to summarize what exactly a registry is, in case of custom API server, registry is something that implements the verbs that are going to be registry is something that implements the HTTP verbs for your REST endpoints. I hope that makes sense. And let's quickly go ahead, and I would like to show you how exactly this looks like. So if you look into, let's say, the creator interface, this is package, registry, and then REST package. Here we have creator interface, and what it does is it has obviously create. So if your implementation, in our case we are going to use, I'm saying generic registry, if I had another implementation, another type, let's say, and if that type implements this particular interface, it means that my resource can be created using my API server. Does that make sense? Similarly, we have, let's say, getter here. So if the registry that I'm using, if that registry implements this particular method, it means that the resource that is served by my API server is gettable. Does that make sense? I hope that makes sense. And so we very briefly talked about registry, and then these create, get, and other operations can be customized using strategy. So there is something called strategy as well. So we already talked about registry. Registry implements the HTTP verbs, let's say, and strategy can be used to customize the behavior of generic registry. So for example, let's say using registry, we can create a resource, but if we want to, let's say, before creation, we want to, let's say, validate the resource, all of those customizations can be done using strategy. So I hope this registry and strategy makes sense now. So registry, like I said, is a kind of concept, or is a thing that implements the HTTP verbs, and the exact type that we are going to use is basically this type, the type store from generic registry package. And if you look into the store type, it implements the methods that we just talked about. For example, it has, if you see, create here, and it should have get, obviously. So it means the registry, generic registry dot store, implements all these creator getter interfaces. And like I said, if your registry is going to have all those functionalities, all those verbs supported, if you implement all the interfaces from this particular package. If you just implement getter, you don't implement creator, you would not be able to create the resource. If you just implement creator, not getter, you would not be able to get the resource, but you would be able to create the resource. So it depends on how many interfaces are implemented by this registry type that you are going to write. We are not going to write our own type. We are just going to use the generic registry.store type because it implements most of the resources, sorry, most of the interfaces already. So let's go ahead and create the registry and the strategy. So I'm going to create a new file here. I was thinking if we should create another package. So let's call it package and then store. And in store, we are going to have a file called registry.go. And in registry.go, like I said, we are going to use this particular store here. This implements the interfaces that we just talked about. And I am going to directly have, let's say, a type called cluster registry. And this type is this is the same type that we talked about here. This is going to be treated as the registry that is going to implement the HTTP verbs, but we don't have to write that implementation because we are going to use the store type that already has the implementations for the verbs. So I'm going to import this package. So import, and then we are going to call it I think we can go ahead and refer the book here. So registry and strategy. So this is what we are going to implement. And we have a cluster registry, and then we are going to use the type from generic registry, and we are going to let's say I'm going to call it generic registry dot store. And then I'm going to have a new function that we see here, and this function is going to return this new registry that we are working with. And this new rest is going to return registry.rest. Hold on, let me quickly go ahead and find that type. Let me pause the video and then I will find this out. All right, so what's happening is because we have this type and we are treating this type as registry that is going to going to implement all those creator getter interfaces, we are just going to return this type itself. So cluster registry, and then we are going to have the error, obviously, and it's going to expect scheme, and then ops getter, and it's going to be generic dot rest options getter, and then we are going to return cluster strategy, and let's create a new instance of this type. So and we are just going to return that. I hope that makes sense. So what we are going to do here is, if I try to kind of recap, we discussed that registry is something that implements the HTTP verbs. And for us, we don't have to write our own registry. We can just use store type from generic registry, because that store type implements the interfaces that we are interested in. And then strategy is something that can be used to customize whatever is done using registry. And this new rest function here gets us the generic registry, let's say. So now what we are going to do is, and one other thing that I would like to highlight is, we are doing this generic registry and strategy because we would eventually like to do the second step here, because we have registered the go types into the scheme, but we have not actually made the resource available as an endpoint. We need to kind of install that, and that can be done once we have registry and strategy. So let's just go ahead and try to implement this store. So in store, we obviously have new func. If we look into the book here, obviously, and as the name suggests, when you interact with API server and you try to get a resource, this is the function that is used to kind of convert that resource so that it can be returned to you, it can be shown to you. And we are just going to return the v1 alpha 1 dot, or not v1 alpha 1, but we have to use the internal type. So cluster dot cluster, and then we also have to register the new list func, and it's also going to return cluster dot cluster list. And then we are also going to have a default qualified resource. So default qualified resource is going to be cluster dot resource, and then we are going to have the resource name here, and then we are going to register the strategy. So before, actually, because we don't have a registry right now, let's go ahead and create a registry type. So if we go ahead and look into the, sorry, not registry, but strategy. So if you go ahead and look into these interfaces here, let's say rest create strategy. Let's just look into this. So this is strategy for, let's say, create verb of rest, I would say. And these are the kind of customizations that we can have for the create. And if you can see here, obviously we can configure namespace scoped, prepare for create. We can also obviously validate that resource if we want to kind of display some warning on create. And if there are some other things, for example, sorting, etc., that can be done in canonicalize. Yeah. So this is how the strategy looks like. And we have to have a type that implements the strategy, so that strategy can be wired up with the registry here. So this is the registry, and we need to create a type that can be considered as strategy, and we have to wire that strategy with the registry. So let's just go ahead and try to create a file called strategy.go package store, and type is cluster strategy. And once we have this type, let's also write a function called new cluster strategy, and it gives us the cluster strategy, and it returns a new cluster strategy type. Now, if I just go ahead and use that strategy, so strategy equals to new cluster strategy, and if I just use that strategy for, let's say, create strategy, this would not work. And let me tell you the reason. The reason is, if we look into the warning here, it says this particular strategy cannot be used as REST create strategy because it doesn't implement the method canonicalize. We are getting complaint just for canonicalize, but we are not implementing any of the methods from REST create strategy. So that is the reason we are getting this complaint. And let's just go ahead and try to implement that. So let's look into the strategy type. So we are planning to use the where is create strategy? So we should be able to figure out, so create strategy and rest create strategy. Let's just go ahead and make sure that we implement all of these methods. These are the interfaces again. So we'll have to make sure that our type implements these methods from these types as well. So for example, object typer and name generator. So let's just go ahead. I'm going to copy everything from here, and we are going to paste that in our strategy, and we will make sure that our type implements these. So cluster strategy, and our resource is true namespace scoped, so that is the reason we are returning true. But don't worry about implementation of these methods yet. We are going to look into that in much more detail later. Right now we are just planning to kind of satisfy the interface so that we can use the registry properly. Okay, so now we are still going to see the problem because there are two other interfaces. It shouldn't have the pointer receiver. And if you see now, we are getting the issue for generate name. And if you remember the reason, we are getting that problem because we have still not implemented the methods from these types. And we are not going to actually implement that. We are going to have fields that are going to, let's say implement those types. So we are just going to use those from here. Okay, so what it means is now at least the compiler doesn't complain because our type itself has kind of those methods, let's say, because we have this type embedded into the cluster strategy. And we are going to return. So object typer is going to be, I think scheme can be used as object typer. So scheme is going to be runtime dot object typer. Okay, and then we are also going to pass the name generator. And do we have something called default name generator? I think we do. So simple name generator. And so now if we go to registry.go, if you see, now we don't see that compilation issue because now this new type that we have, this type is actually a strategy. And we are going to have the other strategies. So update strategy and delete strategy. So we are going to use the same type, but obviously we can use different types for update and delete. And we are getting this problem because we are getting into this problem because right now our strategy just implements the rest create strategy. It doesn't implement rest update strategy and rest delete strategy. So we have to go ahead and we have to implement those as well. So let's copy the methods from update. All right, so create strategy, update strategy. So we have to copy the things from here as well. And we have already implemented some of the methods. So we don't have to implement all, but let's go ahead and try to do this. And you might be able to see that using this strategy now, we are able to customize if create is allowed on update or not. So these are the kind of customizations that we were talking about when we discussed how strategy can be used to customize what registry is doing. So return false for now. We already have canonicalize, so we are not going to implement this. But if you want to have separate canonicalize for update and create, obviously we'll have to have two strategy types, one for create strategy, one for update strategy. But we are, yeah, we are not going to do that for now. Maybe in future videos. All right. So now if we go to registry.go, we are able to use that strategy for create, update, as well as delete strategy. The other thing that I would like to add is, so if you see here, generic dot store options. And then we are going to pass rest options, options getter, and then attribute functions. We are going to implement it later. We are not going to implement it right now. And then we are going to complete these options. So we have store already, and we are not obviously going to, we are not specifying all the fields here, and we want defaults to be automatically kind of configured. So that is the reason we are going to call store dot complete with options. And what it does is, if we go ahead and look into the implementation, it tries to, so there are some things that are mandatory, and if those are done, it tries to initialize some of the things automatically. So, or it tries to populate the defaults automatically. So we are going to pass the options, and then we are going to all right. So now that we have registry and strategy, let's go ahead and try to do the second step here. So if you remember, we said that to make an API actually available and get served from the custom API server, we will have to do two things. One is registering that in the scheme, and the other is installing that in the resource path. So let's just go ahead and try to do the second thing now. So we are going to, yeah, so this is what I was talking about. So API installation, and let's just go ahead and try to install our API server. So to do that, if you remember, we already have our config.go, where we try to run the server, and this is the server that has the install API group method that actually installs this resource so that it can become available in the resource path. So what we are going to do is, we are going to use generic server, and in the generic server we are going to call the install API group. So install API group, and in the install API group, if you see, it's expecting generic API server dot API group info. So let's create a resource, a type of that. So generic API server dot API group info, and that needs to be passed here. All right. So what we are going to do now is, we have to properly basically create the API group info. And if we look into this API group info, we have to configure versioned resource storage map. This is the kind of most important thing here, and this basically configures yeah, if you see info about the resources in this group, it's a map from version to resource to the storage. So first of all, we are going to, so this is basically, like it says, it's a map of versions. So let's say my resource is going to be served by v1 alpha 1. So I'm going to have v1 alpha 1 here. Then it's again a map of string and rest. Then it's a basically resource, and then it's the storage. So in our case, the storage is the registry that we have created. I hope that makes sense. So version v1 alpha 1 to cluster is our resource, and then clusters storage is our cluster storage that we have created that uses generic storage. So let's just go ahead and try to kind of use this same logic that we have in the book. So generic API server dot new default API group info, and it expects the group. So cluster dot group name. Okay, do we not have? Hold on. Okay, so this is what we have to use. What? And then we have to pass the scheme. So we already have a scheme created, and then we are going to pass the codec default value of codec parameter. Parameter codec, and then it also expects codec. So we already have codec created in the last video. So if you see here, this is the codec that we have created. And so now that we have default API group info, what we are going to do is, if you remember, the API group info has a field that sets version with resource to the actual store implementation, and that's what we are going to create now. So v1 alpha 1 storage is going to be map of string and rest dot storage. So So this is what we are looking at. So now we are going to create this particular map. So once we have this particular map, it's going to have resource and the storage implementation. And the type here is rest.storage. So let's just use that. Okay. And once we have that, we have to basically use our clusters resource, and then we have to initialize this map with our resource and the actual storage implementation. And our storage implementation, if you remember, is cluster registry that can be get using new cluster registry, sorry. So registry, and let's call it store dot new cluster registry, and it expects scheme, obviously. Hold on, not new cluster strategy, but it's called new rest, that returns the cluster registry, and it expects the scheme, obviously. And then we are also going to pass the generic config dot rest options, generic config dot rest options getter. So it returns two values. Okay, so now what I would like to highlight is when we looked into the API group info, we were able to see this particular important field here, and we had version to resource to store map. So what we had was the version to sorry, yeah, version to resource to store map, and this is the map that we have already initialized here using v1 alpha 1 storage. So now we have to have another map that maps the v1 alpha 1, and the value is going to be v1 alpha 1 storage. I hope that makes sense. So now we are going to kind of do API group info dot version resource storage map, and then v1 alpha 1 equals to v1 alpha 1 storage, and we are pretty much done, I would say. So what we have done now is, if I try to summarize, we have created a registry. Registry implements the default HTTP verbs for us, so we don't have to implement those. And we have created a local type, and this local type kind of embeds the generic registry.store, and that type implements all the generic registry interfaces methods to add the functionality. And once we have the registry, we have the strategy to kind of customize the behavior of default registry, because like I said, once we have the registry, the implementation is in stores type, so we don't have a lot of control there. So we can customize that using strategy, and strategy can be hooked into registry using these fields here. And once we have this, we can populate the store properly using complete with options, and then we can hook all of these things together using install API group. And I hope that makes sense. Let's go ahead and try to run this again. Our motive is to actually see the resource that our custom API server serves now. So go run main.go, and let's see what happens. Okay, and it says must have a non-empty singular qualified resource. So there should be a field, if I remember correctly, singular qualified resource, and it's cluster.resource. For singular, we are just going to use cluster. Resources are usually plural, so I'm not really sure, yeah, what exactly singular qualified resource is here. I think we are configuring, if you see here, singular name of the resource, and it's cluster for us. So let's just go ahead and try to run it again, and let's see what happens. So table converter must be set. So let's just set the table converter as well. And I think we can refer the book here. Okay, so we don't have the table converter. I think we are going to just use default table converter, and it expects the group resource, and we are going to use clusters. Now that we have the table converter, like the name suggests, it's used to even when we run, if you remember, kubectl get resource and things like that. This table converter is used to transform things in showable manner. Let's say I'm going to run the API server again, and let's see what happens. Okay, unable to get open API models. Open API v3 must not be nil. So let's just go ahead and try to do that as well. So config.go, and in config.go we are going to install the OpenAPI, configure the OpenAPI models also. So we can use the same generic server dot. Let me quickly check my notes here. So once we have the config, OpenAPI v3 config equals to generic API server dot default OpenAPI v3 config, and we are going to register the OpenAPI kind of code that we have generated, and we have that in generated, and then OpenAPI. So this is the package generated and OpenAPI. So we are going to use that generated. Gen open API. Okay, and then definition namer is going to be default. So open API dot definition namer. We are going to kind of customize these things later, but right now I'm just trying to get our API working. If I very briefly try to talk about how exactly open API is used. So when, again, if we go back to this particular diagram here, the main API server tries to talk to the custom API server. And sometimes, for example, let's say if you run kubectl explain, it tries to show you the schema of the resource. In case of CRDs, the custom resource definitions are used to show you the schema, but in this particular case, main API server doesn't really know about the schema of that resource, and that's why the open API spec is necessary, so that main API server can respond with the kubectl explain and other similar commands. So now that we have the OpenAPI v3 installed or configured, let's go ahead and try to run the API server again, and let's see what happens. Okay. Unable to get open API models. It looks like So it's on generic config. I'm assuming we got into that problem because we installed the API group first and then the open API spec, but let's see. Okay, so now what I'm going to do is I'm going to run the API server again. Okay. So server config dot open API. So this is where we return the cluster config, and this is where we create config from options, and that's why this is where we have to install the OpenAPI v3 config. I just looked into my notes, and let's just go ahead and try to run this again. Okay, so now that the OpenAPI problem is gone, we are seeing this particular problem, and it says, if you see, the list options is not registered. So if you remember, when we were looking at the scheme, we registered everything, not everything, but we registered the two types. And now that we are running, it says the list options is not registered. So it looks like there are some standard kind of types or core standard types that we still have to register in our scheme to make sure the things are working properly. So to do that, what I'm going to do is I'm going to refer the code here. So these are the kind of standard types. If you see, we got the problem for list options, and we have to kind of register status, API versions, and things like that. So let's just go ahead and quickly try to do that. So meta v1 dot add to group person scheme, and then schema dot group version. And like I said, what it does is it makes sure that the for example, let's say if we get a resource, we also get status, and the status is not by default registered here. That is the reason we have to register all these types. The similarly, let's say list options that we got the error for. So now let's go ahead and try to complete this. So schema dot group version, and then group is empty, and then version is v1, and then we have to register all these unversioned types. So meta v1 dot status, meta v1 dot API versions, meta v1 dot API group list, and then meta v1 dot API group, and meta v1 dot API resource list. I think this is the same thing same type that we get when we run kubectl API resources, but I'm not 100% sure right now. And that is the reason we have to kind of register these types. So let's just go ahead and try to run it again. And let's see what happens. Okay, so now if you see the server is running again, and if we list the APIs, wow, so this is exactly what we wanted to see. It clearly says that the new server that we have written, if we go ahead and look into this diagram again, this new custom server that we have written, this new server has an API now, and that API is available on viveksingh.dev group, and then version is v1 alpha 1. So this is where that resource is available, and this is the endpoint that's available. And if you see API group list is being returned, that is the reason we had to register all these types here. Otherwise, by looking at scheme, whoever is trying to understand how to do the conversion wouldn't know what exactly API group list is, or how to kind of convert this response into API group list. So now that we have this endpoint working, it simply means that now our resource is actually available in the custom API server, and now we can interact with that particular resource. So I think we are already way past time, so I'm gonna wrap it here. And if you have any questions, feel free to comment them, and thank you for watching.